Ms. Quinn and Vitalik Buterin, founder of Ethereum, to the stage. Together, we will open a space to gift box as a symbol of our appreciation for their remarkable contributions to the blockchain community. Now, let's give them a round of applause. One more big applause. Hope we're gonna have a really explosive year ahead. Thanks, Ms. Quinn and Vitalik Buterin. And right now, I would like to invite to the stage co-founder of Ethereum, a man whose intellect has reshaped the digital landscape, Mr. Vitalik Buterin. Guys, let's give him a big applause.
Okay, hello everyone and good morning. Glad to see so many people coming out here, and definitely great job on the organizers for choosing such an actually interesting and fascinating venue. So looking forward to spending the rest of our 2 days here together. I hope we're going to have lots of fun. So today I wanted to talk about a topic that I think a lot of people have been thinking about for a long time, which is the intersection of blockchains and AI, right? Now, this is one of those areas where a lot of people have been trying to look for intersections for probably almost 10 years now. Almost every time I go to a conference, and when people ask me many questions, often at least one of the questions is about, is there some kind of AI application that fits in here? And at a very high level, you can kind of see why people think that there might be good synergies, right? AI and blockchains are both very important fields in technology, they have some kind of interesting properties that seem like they complement each other, right? So AI is centralized, blockchains are decentralized. AI is not very transparent. Blockchains are all about providing transparency. So there's a lot of people that there's a lot of people that have this kind of very intuitive idea that there's some kind of natural connection between the two that just makes a lot of sense, right? But I think the big challenge here is basically asking the question, we have some of these very high-level ideas about how blockchains and AI might connect with each other, but how do these ideas how can they be realized in actual applications, right? What actually is a specific example of an actual application that has some kind of blockchain component, maybe some kind of ZK component, and also has some kind of AI, and where it actually makes sense to put those two things together, right? You're not just combining buzzwords, you're creating a solution that actually makes sense and actually works for people. So my view about this is that there's 4 main categories that we can think about. And the way that I think about these 4 categories is, the first is AI as a player in the game. The second is AI as the interface to the game. The third is AI as the rules of the game. And the fourth is AI as the objectives of the game. Now, when we build blockchain applications, we often think about blockchains as being platforms that let us create games. Now, sometimes when we say game, we mean the kinds of games that people play to have fun. But more generally, yeah, we mean some kind of environment where different people can come in and interact with each other. That environment has some kind of rules to it, and the rules are designed so that when people come in and when people interact, there's some kind of outcome gets accomplished. And so the question is, if you have some kind of blockchain-based system, could be a smart contract, could be a DAO, could be something else, then like in what piece of that is the piece where an AI can actually fit in? So the first answer here that I have is AI as a player in the game, right? So one thing that we already have, and actually that we've had for about 10 years, is AI is doing financial market arbitrage, right? Any kind of platform that has any kind of finance, you're going to have market makers, you're going to have traders, you're going to have bots. And this is true in traditional finance, this is true with financial applications on top of blockchains, it's true anywhere, right? So this is just like one kind of intersection, and we don't really think about it as an intersection, but it's something that people have been doing for 10 years, and like it is something that makes sense. But in the blockchain space, I think we often like to say that like finance is only the first app, right? The most interesting thing about the space is what other kinds of applications you can build on top of it. And I think here too, right, you can ask the same question. We already have AIs playing in financial markets. What are some other examples of AIs playing in games that might make sense to come up with and try to implement? One thing that I think is going to happen soon is AIs in prediction markets, right? So prediction markets are becoming an increasingly hot topic over the last few years. Basically, the idea is that if you want to try to get like more accurate information about things that are going to happen in the future, you create an open market, people can make bets on it, and you have a market where people who have different opinions about what's going to happen can trade against each other. One of the challenges with prediction markets is that they're very, they have a hard time succeeding unless there's a lot of people who are participating, right? If you have hundreds of participants, if you have thousands of participants, they can work well, but if you only have a very small number of participants, often they don't work very well. And so for questions that are not extremely popular, often prediction markets so far have been weaker in practice than they are in theory. So this is one of the places where AI can come in. Basically, instead of just having people participate and make trades, you can have AIs come in and make trades, and you can have AIs that can read the internet and that can make more complicated judgments about all kinds of questions, and like this becomes a higher level game, right? Instead of having a game that is about you coming in and making your own answers to each question individually, the game is about who can make the best AI that can answer these questions the most accurately. And if you can answer the questions the most accurately, then you can get the most revenue. So this is something that Omen, which is a prediction market from the Gnosis team, has been experimenting with. This is a screenshot of AI Omen. It's a live demo. It's actually live and already working. But this is also just only kind of one other example. Going further beyond this, right? Another example is you can make markets for arbitrary questions that AIs might want to ask, or that people might want to ask, right? If you have some kind of a question that you want to ask, and you want to get some kind of high quality answer to it, then you can create an open market and you can ask the AIs. Now, the purpose of the blockchain and the purpose of people participating in the blockchain mechanism will be to basically provide the incentives, right? So people can do spot checking. People can spot check a small number of different questions. And you can have AIs participating, and you can have AIs potentially answering a much larger number of questions, very high volume, very low cost. This can be useful in decentralized social media. It could be useful in DAOs. It could be useful in all kinds of different applications. So AIs as players in the game. This is one option. AIs as an interface to the game is another one of these really important things, right? So what do I mean here? So today we have blockchains, and when users are interacting with a blockchain, users are generally interacting with a wallet, right? So who here has used an Ethereum wallet in the last week? Okay, in the last day? Good. So the wallet, the word wallet, I think, is a little bit incorrect because, the word wallet, means money, but it's really not just about money, right? A wallet is like your entire interface to this big decentralized ecosystem that has all kinds of applications on it, right? And at the beginning, maybe 5 years ago or 10 years ago, wallets were fairly simple, fairly automated pieces of software, right? A wallet, you would just store your key. If you want to do something, you would click, and then the wallet would have you type in a password. It would have you approve, and it would be pretty basic. Today, wallets are becoming more and more sophisticated, right? So what's happening with wallets today is you're starting to have things like, for example, MetaMask has an anti-scam feature, right? They have a list of different of addresses that MetaMask knows are connected to scams, and if you try to access them, then it gives you a big warning. There's another wallet called Rabby that has a built-in transaction simulation feature. So when you are signing a transaction, it actually shows you these are the effects that the transaction is going to have. And if the transaction looks dangerous, then it shows you more warnings. Right, so wallets are becoming more and more complex pieces of software that are really not just being these kind of completely neutral gateways to just let the user do what they want, but to try to actively inform the user, actively protect the user, actively kind of be this layer in between the user and the applications that's there to be this more sophisticated actor that actually looks out for the user and protects their interests. Today, this is all done with simple algorithms. I expect over the next 5 years, this will be done with AI as well. So that's the value of AIs as an interface to the game. So third category is AIs as the rules of the game, right? So this is where I think we start getting into some of these kind of deeper and more challenging applications of AI. Basically, imagine using an AI as an oracle to give final judgments about some kind of complex question about the outside world, right? So for example, you could have a price oracle, right? And you could imagine an AI that searches the internet and actually tries to determine what some particular price is. Another good example of this is in the WorldCoin project, right? So the WorldCoin project is trying to give people one world ID to every unique person. And if you have a world ID, then you can get some quantity of world coins every 2 weeks. And the way that you sign up for WorldCoin is by scanning the orb, right? So who here has a world ID? Okay, a few people, that's good. Now, in order to tell who actually is a person and who is fake, right? In order to kind of tell the difference between a person scanning and making a deep fake of a person and printing out a picture and then trying to scan with the picture, they have pretty sophisticated AI algorithms inside, right? Right now, this is all kind of fully trusted. You have to trust them to have AI algorithms where those AI algorithms cannot be exploited by random attackers and cannot be exploited by the team, right? So right now there's a lot of trust in the system. And I think there's an interesting question of can we use cryptography to try to reduce the amount of trust, right? Can we try to use cryptography to try to actually make AIs that are more secure and that are closer to being trust-free in the same way that other kinds of programs are? So the big problem here is adversarial attacks, right? Two kinds of adversarial attacks. They can come from the inside and they can come from the outside. So in the traditional world, generally you worry about outside attacks and you solve outside attacks by just like hiding everything, right? The less you know, the harder it is to attack. But in the crypto space, I think when we believe in decentralization, we believe in making systems secure against the inside as well, right? And making systems secure against inside attacks is, I think, really worth doing, but it is also more challenging. So adversarial attacks. Here are some two interesting examples of this out in the real world, right? So on the left here, you have a picture of a cat. On the right, you have a picture of a cat, but if you ask a particular AI, the AI will tell you it is very convinced that the picture on the right is a dog. Why? Right? Basically, what you can do is you can train an attack where you can identify very tiny changes that you can make to the cat on the left that will trick the AI and make it think that the cat with a few very small changes is actually a dog. Basically, it's like optical illusions, but optical illusions for robots. The problem is, if you can see the inside of an AI model, and basically, the more you know about an AI model, the easier it is to train extremely effective attacks. Now, what we have on the right here is basically adversarial attacks that take the form of a face mask that you can wear, right? Basically, what they did here is they took an AI for facial recognition, and they optimized an attack where the attack is that you wear this mask on your forehead, and if you have a mask on your forehead, then the facial recognition AI does not recognize you as a person or recognizes you as a completely different person. So this is challenging, right? Because if you imagine a system like WorldCoin, you could imagine training an attack against it where something that's not a person can basically wear a mask and pretend to be a person. So this is challenging, right? So and I think the big reason why these attacks are challenging is that they can be trained with only a limited amount of access to the model. You don't even need to see the full model to train an attack, right? These attacks they're actually pretty scary. And they can be, you don't have to fully control an environment to provide an attack. You can just wear a mask. So the challenge here basically is, can we use cryptography to try to protect against these attacks? So actually we can. So what we have over here is, this is a diagram that shows the math of what goes on inside of an AI model, right? And what I think is interesting about the math is that it's a very specific and very structured kind of computation, right? So who here has worked with ZK snarks before? So if you worked with ZK snarks, you know that ZK snarks have very high overhead, right? If a computation takes 1 millisecond to do, maybe it takes 1 second or maybe 10 seconds to prove. Now, AI computation is basically a combination of a large amount of matrix multiplication and a smaller amount of these very simple nonlinear calculations. Matrix multiplication is actually very easy to prove. If you have very large matrix multiplications, you can optimize proof systems that do a very good job of proving them very quickly. So making AI computations be provable is actually much easier than making regular hard computations provable. So you can do this with ZK snarks. You can also do this with multi-party computation, right? You can make a system where you have 3 computers, and each of those 3 computers has one part of a model, and in order to compute, you need all 3 of them you need any 2 of the 3 to participate, but the system continues to work even if any one of them is dishonest, right? Even if any one of them is dishonest, you continue to get correct answers, and no single one of them can extract any significant amount of information about the model, right? So you can do an MPC, and you can actually preserve privacy. You can basically make models where no one can see the inside, not even the creator. And if you make a model like that, then training attacks against it actually becomes much more difficult. So one interesting long-term goal is basically asking the question, can we make a system where we can use some kind of DAO on the blockchain plus some kind of cryptography off-chain, maybe MPC, to both to train a model and to run a model? And if you do this, then because the process for who submits the training data is an on-chain mechanism, it's a DAO, and there's fair and transparent rules that show who can submit, people are going to know that the AI model was created in a way that is open and that is transparent, and they're going to have that guarantee without even being able to see the model, right? No one can see the model, not even the creator can see the model, but because you have this process for creating the model where the integrity of the process is guaranteed with a blockchain-based DAO and using cryptography, you can still have guarantees that this is something that's trustworthy. So you can imagine applications that want to use AI as the rules for the game to try to do something like this. Finally, AI as the objective of the game, right? Basically, what if we want to use blockchain-based mechanisms and cryptography to train better AIs that we can then use for other purposes? So one example of this is what I talked about right now, using cryptography for privacy. Another example of this is using blockchain-based markets and blockchain-based incentives to create open markets that allow anyone to come in and participate in trading a model, right? So 4 categories of application. I think, so some just general conclusions about this, right? So first of all, I think intersections of blockchains and AI are real. They are important, but at the same time, I think it's also important to remember that there's a lot of challenges, and you probably should not try to consider this as kind of the narrative that will carry the entire space forward, right? There's lots of other things. There's lots of other amazing and important types of blockchain applications. Decentralized social, in my opinion, is super important. Continuing to improve on decentralized identity, reputation, proof of personhood, also important. Making better versions of all of the existing applications, also important. Games, also important. DeFi, also important. I don't think that there's one single category that's going to kind of dominate and carry the entire space by itself, right? And I think if we're building a blockchain AI intersection, then the easiest kind of thing to build is AI as a player in a game, right? The rules of the blockchain define a game, and the rules of the rules and the people participating, the humans participating, create the incentives, and then the AIs participate as the players. I think this is a design that is fairly simple. It doesn't depend on any kind of hard technology that's still under development, and you can just build it, and there's a lot of different applications for which I think this kind of form factor makes a lot of sense. So if you want something simple, if you want something that's doable now, I think AI as a player in a game is a great place to start. Now, going forward, AIs as an interface are, I think, important. We are, I think, in the next 10 years of Ethereum needs to really reach users on a much larger scale than before. And I think to reach users well, we are going to need much more sophisticated forms of wallets and interfaces to try to make the experience of interacting with Ethereum both more understandable and easier, and at the same time more safe. But the harder ones are AI as the rules of the game, right? Basically because if you make the AI actually be the rules, then like you're putting a lot of trust into it. And you're putting a lot of trust into something where sometimes it still breaks, right? And we know how to train attacks against it. And so you can try to use cryptography to protect against these things, but the challenges in trying to do this are greater, right? So I think benefits are really great, but challenges are also really great as well. And there's a lot of really fascinating math and really fascinating cryptography that goes into doing these things well. So if anyone here is interested in building AI blockchain applications, first, make sure you have an idea that actually makes sense. An application is not automatically good just because it has an AI and it has a blockchain. First, it has to be good as an application. It has to provide something that's useful. Then the AIs have to provide something that's needed, and the blockchain part also has to provide something that's needed. And if you can figure that out, then great, right? And then the next question is like, how do these two different pieces fit together? And so I think, I talked over here about a couple of different strategies that you can use, there's a lot of room for creativity here. But I'm looking forward to seeing what kinds of things people here come up with. Thank you.
Thank you, Mr. Vitalik Buterin, for sharing useful information with your future vision. And myself and all the guests here are looking forward for the upcoming explosive development of AI and blockchain. And hopefully those of us who can be said to be the pioneers will gain the great achievements. And hope Vitalik will have a lot of help and bring Ethereum more and more successfully.